When we finish to create all our layers, thematic maps for our study area, so the first one is slope. So as you remember, I just divided it into 5 classes. So these areas have highest steep slopes, and most of the areas are plain. So the next one is Savvy map. So during the classification of Savvy, we divided our study area into 7 classes. So these are some areas are water, and the most of the areas we divided into different types of soil classification, which was mentioned in different literature sources by various authors that validated Savvy indexes and correlated them with different soil types, so such as loamy sand, clay, loamy clay, etc. So most of the areas are sand or loamy sand. So the next layer is precipitation. So we summed up the precipitation for the last 10 years, and some areas have higher level of precipitation like this, but other areas have very small precipitation even for 10 years. But in general, the precipitation, monthly and annual precipitation for the study area is low because it belongs to arid and semi-arid zone. So the next is our alignment density. So we first define the areas of alignment where tectonic plates interact with each other, and using line density tool we also first we draw some lines, alignment areas, and then created alignment density tool using line density, and some areas have very high alignment densities like black areas, and some have no alignment areas. So the next is classification. So these areas, most of the areas are considered as barren land, so which is in our area are desert. So some areas are water. So this area was mixed with sand. Actually, this also belongs to water, but this was mixed with sand, and therefore, despite that post-classification correction, ArcGIS still classifies these areas as sand because part of due to sand dunes and the water was covered by sand, and the surface of the water body was covered by sand, and ArcGIS classified this as partially sand. So and the last layer is depression zone. So the depression is the difference between smooth digital elevation model, which was derived using field operation, and we subtracted our raw dam from this field. So we can remember that field sinks in a surface raster to remove small imperfections in the data. So we removed some small imperfections in the data and subtracted raw digital elevation model in order to find out areas which have some just large discrepancies comparing to the raw data. So and the last step will be to just overlay all the thematic layers with each other in order to find out potential groundwater areas. And we also just derive it with HEP analysis, the percentage that we will assign for each our layer. So in order to start weighted overlay, we go to spatial analysis tools and overlay, and this function weighted overlay. So let's start to add all our thematic layers one by one. So slope reclass, and please just as input field choose classes attribute that we created deliberately in order to facilitate our work during the weighted overlay, where I wrote each class with text. So it's adding. see that classes are from 0 to 5 for these classes. So, and the next layer, Savvy, again classes. Okay, so again it's added classes, so it's clear for us to distinguish now, right, and to assign a certain weight for each class during the weighted overlay. So again, this precipitation, that's why please don't forget to write to add the attributes after finishing the map, the layer, and just to write precisely the name of each class and what does it represent in order to facilitate your work during the weighted overlay. So, and the next is depression classes. Okay, so and now see that there is influence in percentage, and overall percentage is 100, and we should allocate certain percentage for each our class, for each our layer, according to our HPA analysis. So first, land use and land cover. No, let's start from slope, because the first is slope. So slope, we find out the slope will weight 30%. So we see that you cannot write float values in weighted overlay. It's only integer values, therefore we should just round the values into integer from float. So don't worry about this weighted overlay as this error. So the next is to Savvy 12%. Let's assign 12%. Precipitation 5%, right? Lineament density. Lineaments, it's 46%. I will assign 45 because it will be too much, I guess, because almost half of the weight will be assigned to lineaments. But it's actually in some up to point it's correct, because lineaments are certainly the areas which where the groundwater areas are located. But anyway, classification now, land use and land cover, I will assign 7%. Depression is depression zones is 17%, right? So we still have 1% left. So I think that we should assign it. Let's assign to precipitation, okay, because it has too small. So precipitation now is 6%. So we could assign it to lineament density. It would be more correct according to our HGP, 46%, but I think that 1% doesn't make a significant difference, so I decided to increase precipitation influence. So now the next step is to this scale value attribute. We now need to assign certain ranks from 1 to 9. You can change, by the way, this ranking. See, there are multiple types of ranking system, but we decided to choose 1 to 9, where 9 is the highest scale, 1 is the smallest scale. So this from 0 to 5 degrees is 1, because the importance will be small. The opposite, by the way. This is the highest rank, because groundwater, just water due to gravity forces accumulate in low steep areas, slope areas, and therefore there is a high probability on low slab areas to penetrate through soil and create groundwater area. Therefore I will assign 9. This one is 7. This one is 6. This one is 5. No, let's assign it 4. and this one is well, almost 0. We can assign 2. Okay. So the next, Savi. So water has the highest probability because water areas always have a groundwater also beneath it. So sand also have a very high probability to create groundwater because sand parent material is large and it has large pore areas, and water it's make it easy to penetrate water to groundwater zone. So that's therefore I will assign 7. Loam is sand, it's close to sand structure. Sandy loam the same, I think. Loam slightly smaller. Loamy clay is 0. No, let's assign it 2, okay, because the clay is very small in the smallest parent material, and it has such a small pore areas, so the water almost cannot penetrate into groundwater zone, and the clay is 0. So the next step, precipitation. So it's easy. So highest precipitation has the highest rank. So we will assign it. We can assign 7 or 8. Okay, let's assign 8. So this will be 7. This will be 5. Okay, and this will be 3. So alignments. So the highest density are 9. So this one, let's say it's 7. This one is 5. Again, it's also many things, depends on your experience in literature review in study area. I could assign different value, for instance, for this 9, for this 8, for this 7, etc. But just it doesn't make a huge significant difference because most of the things depends on the influence, but also this some rankings might just slightly change the probability, slightly change the final result slightly. So classification, again, water has the highest probability, barren land has barren land also have some probability due to precipitation. Agriculture has very high also probability because in agricultural areas intensive irrigation is used. So urban land almost doesn't have a probability because it covered by these are not just urban, by the way, urban and minerals. Remember that we classified some areas as mineral zones and asphalt zones, etc. So no data, this is I think no data, so I will assign it to 1. So several pixels. So depression, and the depression, so depression, highest depression, highest the probability, 9, this is 8, let's create it 7, okay, this is 5, this is 4, 3, 1, etc. So now our ranking weighted overlay is ready, but there are 2 things left. First, we should save it in, let's create a separate folder. So let's save it here and name it overlay.tif. And the last thing, go to environment here. So see that there is this function processing extent. Go to snap raster and choose this no, go to extend and choose your study area. See that the shapefile which I also added to my data frame, and also go to raster analysis. See that there is a cell size and the mask, and we should define a mask again, our study area in UTM format shapefile. So raster analysis, study area, and processing extend study area. Okay, so our influence and etc all ready, and let's click OK. Now it's overlaying according to the data that we decided to assign. So let's wait. So my overlay is ready. So this is my overlay. I can close all my layers, and this is my final overlay. I can just rename it here, but I will not change its actual name in a folder, but I can rename it here to groundwater potential zones. So see that we have several classes here from 2 to 8. So the 8 is the highest probability, 2 is the lowest probability. We can make it easy to understand when we just can merge some classes with each other, close classes. So go to properties, and this is a symbology, and I decide to reduce the number of classes into 5 from 1 2 3 4 5 6 7 into from 7. So let's merge these two classes into one. So by pressing Ctrl, choose these classes. I don't know what is the result of your overlay. Probably you have from 1 to 9 or from 3 to 7, etc. It's up to many factors. It's up to the classes you have, it's up to layers you have, it's up to ranking you assigned, etc. and weight, influence, etc. So anyway, you will have at least in most cases 7-8 classes. So I chose both of these classes, and by pressing the right button of the mouse, see that this window occurs, and I will choose this group layer function. So now it's grouped into one. The same thing I will do with this highest probability classes 7 and 8 by pressing Ctrl, right click of mouse, right button of mouse, group values. So I will say that I will write this very low. This is just will be low. This will be moderate, right? Moderate probability, high, and very high. Let's click OK, and now our map is more visually distinguishable. See that if we zoom, that we can see that this area, most of the areas have very low probability, except the areas which are considered as alignment. Therefore, I was slightly worried that I assigned alignment this very high percentage, because I initially knew that ArcGIS will map only areas which are considered as alignments, as potential groundwater zones. So, but it's clear that alignments have high probability of groundwater, but we are also interested in other areas. For instance, these areas also have, we can see that the moderate probability. See that these areas, as well as these areas, also have moderate or above moderate probability. We can also change we can ungroup values. Let's ungroup them. And let's merge these classes, for instance, group, and these classes, group. So this will be very low, this will be low, moderate, high, very high, and very low will be red, low will be this, and I will choose to very high this value. Okay, let's click OK, and let's change. Well, our map significantly changed. Most of the areas are low, some of the areas are moderate, some of the areas are very small areas are very high, but also very small areas are very low. Probably we can also leave the initial so it's up to you how you will name these classes, but intermediate classes. So this can be low, slightly above low, moderate, high, very high, extremely high, etc. So you can, it's most of the experts divide it into 5 classes, but in our case probably it's more correct to leave it the same, so leave it with the 7 classes. So see that these areas in alignment areas high, these are just moderate, right, or low, most of the areas. So this is the end of our work, but the last step will be just to create visually attractive and representative maps, which will be done in the following videos.